Test corrections part 2. Draw a force body diagram of all the forces acting upon the boy and the boat, including reaction forces. And I already drew the force body diagram that represents this picture. There's always going to be force acting, or gravity acting on the boat, so that's pulling it down. Above will be the force buoyancy, which is the friction of water. With the friction of water, it's moving the boat. This is the boy, the force of the boy, because he's jumping off, and it will have an opposite reaction of this. And the other way will be the F boat, the force of the boat. 3B. If the boy has a mass 20 kg and the boat has a mass of 25, and the boy jumps from the boat starting at rest and accelerates 4 meters per second in 0.25, how far will the boat travel after 8 seconds? Assume the water is frictionless and the boat has begun from rest. So, here's write the information that I know. So you know that there's a mass. Boy mass is 20 kg. And boat mass is 25 kg. As V naught, it starts at rest. So that will be 0. And accelerates 4 meters per second in 0.25 seconds. Okay. How far will the boat travel after 8 seconds? So that's a no. Now, first, you take 4 meters per second, divide by 0.25 seconds. So that will give you 16 meters per second square. No, this is the acceleration of boy. And you know that force equals mass times acceleration. So the mass, this is going to be the mass. This is going to be force of boy. So his mass will be 20 kg. Your acceleration will be 60 millimeters per second. That equals to 320 newtons. So this is the force of the boy. And the force of the boat, this is force of boat. So you take, force of the boat is 25 kg times acceleration, the same thing, will be 16, right? Yeah. What is 16? Okay, I don't have a calculator, so I'm just gonna do this. Hold on. I did something wrong. Force of the boat. Actually, excuse me. No. You take the, no, actually, no, I messed up. So you take 320 newtons divided by 25 kg, which is the boat, okay? And you divide that by 25. And that's their acceleration. So this would cancel out. You divide these, and you get 12.8 meters per second square acceleration of the boat. Okay. So then you would use the equation. Boy, this will be delta x equals v naught t plus 1/2 at squared. And your v naught will be 0 because he starts at his rest. And a is accelerates, so this is going to be 0. So you do 1/2. Acceleration will be 16 kg from here times 0.25 square, and you get delta x equals 0.5. This is the boy. And then for your boat, delta x, same equation, v naught t plus 1/2. You can see 1/2 at squared. Okay, and then you will do this will cancel out. You would get .25. And the time is, I'm assuming you do 8 seconds. So you do 0.25 times 8. You do 8 seconds because you're trying to find out how many was the travel after 8 seconds. So you multiply it by 8. So that'll be 40, 20, so 2.0. 2.0 plus 0.5. So you get 5. 2.05. But when you add this, your answer should be 24.85 meters per second. So I'm not sure if this is the right answer. Yeah, this is what I got, but yeah, this is my answer. But I'm not sure if this is right. Yeah, this is my answer. Okay, I have one more question. Acceleration due to gravity on Jupiter is 2.5 times. Jupiter is 2.54 times radius of Jupiter, 69.9 million meters. What is his mass? And so I assume you use this equation. And what I did was, this is the radius. What I did was, I just plugged in the formula into the formula. This, and I just use this. Plug it back in here, I think. And then this will equal 4886.01. And when you divide this, you get 5.19 times 10 to the negative fourth, I believe. So I'm not sure. Yeah, I think this is my answer. So yeah, that's it for my test corrections.